This is supposed to be, I'm Daniel, dev manager and cloud architect, and I just realized I'm not a developer anymore, which is a shame. And I don't like the session title, just ignore it. This is supposed to be more of a real-world example of how we, at our company, GHX, have tried to, or currently are trying to move our existing landscape over to a serverless global application model. And just to give you a 10-second context, GHX is about supply chain in healthcare. So we connect hospitals, we connect hospital groups, and we, on the other side, connect suppliers, manufacturers, distributors, and it's all about traffic, EDI traffic, so orders one direction, order responses, advanced ship notices, invoices in the other direction. That's what we do. And a big part of that is catalog management, right? Providers, so hospitals have big catalog stores in their MMIS systems, and also suppliers send catalogs to us, and we try to make sense of it in the middle. And as it so happens with larger companies, we have been a number of smaller companies, so there's always mergers and acquisitions. So we have still individual catalog systems in all our current target markets. So there's one in North America, there's one in the UK, there's one in Netherlands and in Germany. And of course, they're still alive and they each have a different item schema, catalog schema. Surprisingly, over time, they were all supposed to talk to each other. How could that happen? And there's always the theory, okay, what if we expand into yet a different market, or if we have additional acquisitions and suddenly inherit additional catalog systems? Let's not do this. So, but still, it's catalog management, so all of these systems are doing a reasonably similar job. What's the problem? Operational efficiencies. There's content operations teams that need to make sense of all this, that need to make sure that catalogs go this or that direction. They have different schemas, so we have mappings and we have conversions in place to move catalog data back and forth. I mentioned expandability, so what about the next target market? And the whole thing is not global, so we said we need to have a new global solution. Or if I put that into wrong button. If I put that into developer words, it's more like that. So yeah, that's what happens. Legacy catalog processing. It was built. So one of these systems was built like 15 years ago. It's still alive. It works reasonably well in that individual target market, but it's not extensible. So we have all kinds of stuff going on as data moves through the system. We added stuff over the years, and it's just unmanageable. And this all happens just before the write into the data store happens. So that might take a while, and it's really not good in terms of latency. So no, probably not. The path forward. So we knew our business requirements. We know about all our legacy systems and what they do. And so this was our baseline, and we thought, okay, we have a number of file types. We have a number of sources, like really files, or we have APIs that enable us to ingest data. Data is coming in from multiple places, so from suppliers, from hospitals, from hospital groups. That's one thing. So we have a inbound traffic thing. And the other thing is we know we need to consume and process and report on that, on top of that data in multiple ways. So there are a number of systems and services and subscribers to catalog information, and that's it. And that was our baseline, and we decided to create that strict separation there in the middle. And we also decided that no, we don't want files on S3 be passed around so that every system can extract what it needs. We want a single source of truth in the middle, and that's what we're currently architecting. Nothing, just a side note, nothing of that exists yet. We're just building that platform, so it's your guys' task to rip it apart and tell me afterwards why this all will fail. Looking forward to conversations. So we need a single source, or we want a single source of truth in the middle, and we want a decent ETL stack that ingests all that data and harmonizes it and unifies it so that we have a a single thing in the middle. And then something needs to happen. If it's in the data store, it needs to get out of that again. And that works through an event model where each of these services on the top subscribe to these events and are basically passed on this information to make sense of it. Couple of deep dives into individual parts. ETL, I mentioned before, each would have a different schema, each of the catalog systems. So we have a catalog with like 4, it's fake, obviously, catalog with 4 attributes. We have another catalog with different attributes, although there's an overlap of 2 of those. Yet another has completely different attributes, so we know we need a schemaless data store. It's not something that I would want to push into SQL Server. Then we need to, on a global scale, define, okay, what makes one item in one market from one supplier, for example, unique. And so the system needs to be able to infer their own internal key information to make it globally unique, because obviously a item code, a supplier part number can pop up in many catalogs. And the decision then was pretty obvious to us in terms of serverless. It's going to be DynamoDB because we're an AWS company, so to speak. The ETL process, so usually we have files coming in, and the first step it takes is we map the catalog information line by line into our internal canonical format. That's, on one hand side, it is our internal description, our internal schema description. So we have an internal field for what the supplier part number is, and also we turn it into JSON, just for the sake of it, so that every single line, every single item from that point on looks exactly the same in terms of structure, and we derive the item key. Next step is, because we're not only getting like catalog files, we also extract catalog information from multiple other file types like purchase order history. So we need to deduplicate what we find in these files, because obviously in purchase order history, one item can pop up hundreds of times. Next step is delta. We only want to write to our data store if the item has an actual change. So we derive a item hash of all the attributes of the item, and we fire that item so we fire item key at the data store, we receive back the item hash, and if it's the same as the item hash that we have just calculated from the new file that's incoming, we just ignore it because it hasn't changed. And then finally, we have individual events that we shoot at the database. And the aim here is to be global and to have individual services that have a specific purpose. From left to right, left is very specific to where the files come from. Right is supposed to be very generic, it's the same across all the data sources, across all the markets. So we try to push the specific stuff over to left as much as possible, so that we have generic services, and each of these smaller arrows there are supposed to be service or serverless service offerings. Let's put it like that. And yeah, let's make them as generic as possible. Next, detailed look at the events. So I mentioned before, we have Dynamo as a database, and Dynamo has this nice feature of item change triggers, where every changed item in the data store pops up on a stream, on a Kinesis stream internally, that you can consume. And from the other slide you saw, we have at the top these consumers, these catalog subscribers, these other systems that need to be aware of item changes. So actually what we want and need to build is that guy. If you remember from the MIB movies, thought about calling him Jeff. We have that item change event stream, and we are creating a dispatcher function that just consumes these items from the stream one by one. And as I said, all catalog systems in all current markets are doing a reasonably similar job. And so our task is to take that knowledge, not to take the code per se, but take that knowledge and transfer it into a list of service offerings or service functions there. Manu earlier today mentioned don't copy and paste, don't lift and shift existing code into serverless, that wouldn't work. And this is exactly what we are not doing right here. We migrate tasks from legacy systems in terms of, hey, we know an item needs to pass through a list of, I don't know, 5,000 regular expressions to find matches. That's stuff that the existing system does. We know we need that, but that sounds like a nice little function that we can put into Lambda. We know we need to keep it very open to changes because we don't know what comes up next. We also don't want to deploy the full stack for each change, but if we can just deploy individual changes, and also static workflows wouldn't work. So we couldn't take an approach like step functions where we push each item through, because what needs to be done is not static. So we need a rules engine that we build into the system. What happened there? It's okay. And so this dispatcher function is supposed to read a dispatcher config store where it finds rules for processing. Those rules have a name, they have a description, they have conditions, and they have a list of actions, and we separate their success and failure actions. If you look at how such an event looks like, we have an event ID, we have an event name, which is add, modify, delete, and the key, and we have the full delta. So we have the new image and the old image. Actually, it's not a delta, but it's the full version before and after the write. And now we can create a rule that says, hey, if attribute C has changed or not changed, or if it's greater than the value before, then push the item into this service. And the actions at the bottom there are actually, in our case, services in AWS, like ARNs of downstream services, where we just push this event into. And those services are then responsible to make sense of all that. So this looks kind of like that. We have a couple of, and this might be, I don't know, 50, 100 more services that need to be populated there. They might do their stuff and write back to the catalog data store. They might process the information and pass it on to other services or to external catalog subscribers even. They just need the information and do their stuff. We populate search engines. It can be all kinds of stuff, and that's really up to what the product management team basically needs as part of an item change. And so we know the dispatcher is not a broker, so it's not supposed, just in terms of workload really, it's not supposed to wait for an answer from a downstream service. We really just send the information there. Every service is supposed to be highly decoupled, so ideally they don't know of each other, they don't talk to each other, but every time one service needs information that the other service calculated or came up with, it's supposed to go through the item in the single source of truth, in the single data store. So service A writes back to catalog data store, and that creates a new change event, and then service B can react to that change event. That's the plan. So we keep them separated. The model is fire and forget, and that also supports us to use a buzzword, limit blast radius. So if service D fails, that doesn't affect at all the dispatcher, or is not supposed to affect the dispatcher or other services. And to do that, we create a layer between that. So the dispatcher function is not supposed to call downstream APIs or other lambdas or whatever. The dispatcher is just supposed to talk to, I don't know, Kinesis, SQS, whatever streaming or queuing service is available and makes most sense for the service that needs to consume the data. That's the plan. And so, based on the rules, the dispatcher might decide, okay, service A and B need to be notified, service C and D not, a couple of other services, a couple of search engines, and it's their job then to consume that data. And as I said, if service D fails, well, it just doesn't consume from the stream or from the queue. And if we take, I don't know, an hour to restore the service, then processing can go on, and it doesn't affect the whole overall system. We need audit, we need trace information, so operations teams need visibility into all of that. I've heard that dev probably needs the same. We need to know what happened in the system and what was the result of that event. And well, we need full audit, we need full trace, and the way we're building that is we have a live, that's one item. We have, I don't know, version 4 of the item that is live, and we use the change event stream as well to push all the previous versions into an audit structure, into an audit table, so that we have everything available, and operations teams can look up on an attribute level basically what changed on all of these items. And what also needs to happen is all the services that do something with the data, or that consume the data, or that change data, they're supposed to emit trace information and correlate that with all of the individual changes there. So if as part of the change from version 0 to version 1, 4 services have been notified, these 4 services are supposed to, with a correlation ID, which is the event ID that you saw earlier, to put trace information along with that specific change event there. And that needs to be a core service in our respect. So the dispatcher function will push into the audit log, will push into the trace log, and actually that might be the same data structure going forward. And also all of the services are supposed to write back to the trace log. Cool, 1 minute left. Versioning, deployment. In that scenario, we could think of multiple, that's just a part of it, obviously. In that scenario, we could think of multiple ways of doing versioning and deployment. One is kind of old school, just publish the new version, bam. Good luck with that, hopefully it behaves. Probably not the best one, and I don't think we're gonna go that way at all. Another scenario could be gradual traffic shifting, as the platforms nicely support that now. So like move 20% of the traffic over to that new service version and keep the rest on the old one, and if it looks good, then gradually move over. Or actually another part of that could be that we deploy a version 2 of a service in parallel, and we clone the events that are coming into another queue or stream, so that we have both running in parallel. One of the examples would be when there is a refactoring. The logic of the service is exactly the same, but it could be more memory efficient, it could be more CPU efficient. It's supposed to do exactly the same thing, so we can do a parallel deployment of that, and based on the trace information that both of them then emit, see, does it look the same? Is it the same? Are there individual items that are off? And if not, then probably the service is not there yet. All right. After all these issues, I think we can go into the coffee break. So that's supposed to be our architecture. Happy to hear feedback, and thanks for listening.